Today's lesson has a familiar topic. It is factoring again. I can factor a polynomial, including finding the greatest common factor. We've spent some time factoring so far, including finding the GCF. To be more exact, today's could say I can factor a polynomial when A does not equal X. In the past couple of days, you have been practicing using something that we call factor X, or the diamond method, to factor something that looks like this, that does not have a GCF, but you could put it in the factor X and find the two things that multiply to get 6 that also add to get -5. Well, this is standard form for a quadratic equation. The standard form is ax squared plus bx plus c. In this case, c is 6, b is -5, and a is this understood 1 right here. Today, you're going to be focusing on polynomials where a, the leading coefficient, is not 1. So let's review for a moment. You should always check first for a GCF. So we're going to look at 5, -5, and 30. Our leading coefficient is 5, so we think about those three numbers, 5, -5, and 30. The lowest number we have to concern ourselves with is 5, and 5 will go into 30. So we are able to divide all of these by 5 to lower the numbers that we're working with. This gives us a 5 times x squared. 5 divided by 5 is 1x squared. -5 divided by 5 is -x. And -30 divided by 5 is -6. So we have practiced getting out a greatest common factor, and this is what it looks like over here when you get a greatest common factor out. Greatest common factor is that number in front, the same number that we divided everything by up here. So after getting the GCF, if there is still an exponent greater than 1, try using the factor X. So this is what we just did on the previous page. The exponent was greater than 1. So you learned the last couple of days how to take this and put these two parts into the factor X and find out what the other two terms are. Now, we're going to do this more in the next few days, where you have a GCF and then you can also use the factor X. But as a reminder, you do know how to find a GCF, and you should know how to find a factor X. But what if there's not a GCF? So we're going to look at 6, 23, 7. 6 is our lowest number, and the things that go into 6 are 1, 2, 3, and 6. 6 goes into 6, but not into 23 and 7. 3 goes into 6, but not 23 and 7. 2 goes into 6, but not 23 and 7. And the only thing they all have in common is 1. But then when we check x squared, x, and 7 has no variable, so there is not a variable part that they share. The greatest common factor is technically 1, but if I divide everything by 1, I'm going to have the same thing. So not a GCF other than 1. If there's not a GCF other than 1, but there is a coefficient at the beginning other than 1, what are we supposed to do? So there's a lot of information on this page. So I'm going to read this top to you. Factoring a trinomial with a coefficient in front of the first term is a longer process, longer than what you practice with factor X. It requires careful thinking and checking. The following steps will lead you to the right answer for every problem of this kind. So if you have a coefficient in front of the first term, and that coefficient in front of the first term is not a 1, you're going to use this longer process, and it works every time. So you're going to do this process, slide, and then you're going to use the factor x, then you're going to divide and reduce, and after you reduce, you're going to take the bottoms of the fractions up. We don't want fractions in our factoring. The short term that you're going to hear your teachers call this, we're just going to call it slide and divide. It is very important that you take notes, ask questions, make sure you understand all of these steps to slide and divide. So we're going to take that example from the previous page and we're going to work on the slide and divide steps. If you were thinking about what we did the last couple days, we are going to use the factor x. But on the factor x, we only used it if this first term was an invisible 1 or an understood 1, which we do not have here. So we're going to do this process called slide. So I'm going to slide the 6 over here to the 7. And when I slide, I'm going to do 6 times 7 and put that as my number at the top of my factor x. 23, the middle term, is still going to go at the bottom. Once you slide, you are definitely going to have to divide. So after factor x, we had 2 parentheses, and we will have 2 parentheses again using the numbers from the sides. However, if you had to slide, after you fill in those parentheses, you're going to divide by the number that you used to slide. So as soon as you slide, set up your divide. Then you do this factor x the same way. My numbers that are going to get my 42 and my 23, I'm going to multiply 2 times 21 to get 42, and 2 plus 21 is 23. You'll remember from using the factor x that you're going to put x times x to get this x squared right here. We don't have to worry about the 6 because we slid it over there, and now we're going to divide by it. So don't get concerned with the 6 since you already used it to slide. The 2 numbers I got were 2 and 21. They were both positive. So I've completed the first step, which is slide. Now I'm going to divide if I can, or if I can't, I will just reduce the fractions. So 2 divided by 6 comes out to a decimal. So I'm just going to reduce that fraction to 1/3. You are allowed to use your Desmos or handheld calculator to get that to reduce. And then 21 divided by 6 also comes out to a decimal. So I'm going to also just reduce this. And that's going to be 7/2. So I've done the slide and I've done the divide. And the short name is slide and divide. But that's not all you do. Once you slide and divide, you're going to do this process that we call bottoms up. And for bottoms up, you simply take the bottom of the fraction and take it up to the front. Bottom of the fraction up to the front. So this is going to be 3x plus 1 now. I'm taking the 3 to the front. And 2 to the front makes 2x plus 7. Now on this problem, I am going to check. I'm not going to check on all the example problems today, but I am going to check this one to show you that after I slide and divide, I do get an equivalent expression. Doesn't look the same, but this is what I just got from my answer, and I'm bringing it over here to check. So I'm going to multiply, and I'm going to use the distributive property. 3x times 2x is 6x squared. And 3x times 7 is 21x. And 1 times 2x is 2x. and 1 times 7 is 7. If I do the underline method, I will see that I have two things that can combine. 6x squared has two underlines, stays by itself. 21x plus 2x is 23x. And then 7 also stays by itself. Hopefully you can clearly see that I ended up with 6x squared plus 23x plus 7, which is what I started with. So using the checking, I can see that my answer, 3x plus 1, 2x plus 7, is the answer to factoring this expression. Now, I showed the checking on this problem. I won't be showing the checking on every single problem for this example video. All right, so we have another example here. We have 7, 9, and 2 as our three numbers. So 7, 9, 2. The things that go into 2 are 1 and 2. 1 is the only common factor for 2, 7, and 9. Also, I've got an x squared and an x, but 2 doesn't have an x. So my GCF is only 1, and dividing by 1 isn't going to change this. So there's not a greatest common factor, but my number in front is not a 1. I can still use the factor x, but I can't put the 2 until I slide. So I'm going to slide the 7 to the 2, which is going to give me 14. And I am still able to use my middle term, which is a 9. As soon as you set up the slide, you know you're going to have to divide. So you can put your parentheses where you're going to put your two binomials, but you know you're going to divide by whatever you use to slide, and I used a 7 to slide. So I'm going to go ahead and write that in, that I'm going to divide by 7 once I fill out my factor x. To get 14, I'm going to do 2 times 7 to get 14, and 2 plus 7 is 9. So I'm going to do x plus 2 and x plus 7. Now I'm getting ready to divide. When I divide, if it doesn't divide into a whole number, then I reduce the fraction. So 2 divided by 7 comes out to a decimal, and it cannot reduce any lower, so I'm going to keep it for now. But 7 divided by 7 equals 1. So that comes out to a nice whole number. After you slide and divide, you are going to do bottoms up. So if you have any fractions, and in this problem I do have a fraction, you're going to take the bottom of the fraction up to the front. So this one's going to change to 2x plus 2. I am so sorry. That was a 7 that got taken to the front. 7x plus 2. And x plus 1 came out to a whole number, so I just keep x plus 1. There was no bottoms up on that binomial. Okay, we're going to use this process again. We have 3 as our leading term. There is not a greatest common factor for 3 and 7 and 6. So we're going to use our factor x, but before we use our factor x, we must slide that number so that there is not a number in front anymore. So I slide that number. 3 times negative 6 is actually negative 18. And my middle term, I get to use negative 7. Then I complete my factor x. I'm going to use 2 times negative 9 to get my negative 18, and 2 plus negative 9 gives my negative 7 in my factor x. Because I have used the slide, when I fill in my binomials, I am going to have to divide. What did I slide? I slid a 3, so I'm going to have to divide by 3. I'm going to take this number, which is a positive 2, and put it in the first parentheses, and this number, which is a negative 9, the second parentheses. Now I'm getting ready to divide. Remember, if it does divide, I just write that number. If it doesn't divide into a whole number, then I reduce the fraction. And sometimes the fraction doesn't reduce, so I just keep it. For example, 2 divided by 3 really looks like 2/3, and 2/3 either comes out to a decimal or we say it doesn't reduce. And then -9 divided by 3, that is a -3. So I get a nice integer there. After you slide and divide, if you have any fractions, which I do, the step you have to do is bottoms up. We take the bottom of the fraction and we move it up to the front. So I do have a bottom right here that's going to move up to the front and change this to 3x plus 2. But I get to keep the x minus 3. I almost wrote a 2 there, guys. X minus 3. It takes practice to be comfortable with these problems. So don't give up. Hang in there. You will be able to figure this out, but it does take practice to be comfortable with these problems. I am going to show you one more. Make sure you have taken very neat notes and that your notes are showing you step by step that you need to slide, then divide, and then get rid of those fractions by doing the process that we just call bottoms up. So here's another example, last one that I'm going to show you today. And in this example, we have 4x squared, 12x, and 9. There is not a greatest common factor for a 4x squared and a 12x and a 9. So we're going to try the process called slide and divide. I'm going to slide this 4 over here to the 9, and that will be the top of my factor x. 4 times 9 is 36. And the bottom is the middle term, which is 12. To get my 36, I can do 6 times 6 to get 36, and 6 plus 6 for 12. I have to be careful to not just put x plus 6 and x plus 6. I have to remember that I used this slide, and if I used the slide, then I have to come back and undo that slide with a divide. Whatever I used to slide is the same thing I'm going to use to divide. After you divide, you check to see if you have a whole number, whole integer, or you reduce a fraction. In this case, 6 divided by 4 comes out to 1.5 on a calculator. So I want to change that back to a reduced fraction, which is 3 over 2. And both of them are the same. After you divide, you do that process that we call bottoms up. If you have a fraction, you want to take the bottom of the fraction up to the front. So I'm going to take this up to be 2x plus 3. And this one up to the front, the same thing, 2x plus 3. I do want to draw your attention that I have written the same thing twice, and this can be shortened to be 2x plus 3 to the second power. That means I'm using 2x plus 3 twice. Now, I want to remind you that this takes a lot of work. Again, it takes practice to be comfortable with these problems. So make sure that you are using either a whiteboard or a notebook to work these out so that you are getting all of the steps and not missing anything that could just be a simple thing causing you to get it wrong. Take your time, work carefully.